do here and where we came from. We're going to start out with a student group, and the student group starting out for us today is Oswego East High School Invent Team from Illinois. They have invented Algae Air, an indoor air purification device using algae. So Oswego East, if you could please come up. All right, turn it over to you guys. Very good.
Hello, we are the Oswego East High School Lemelson MIT Invent Team from Illinois. I'm Aaron Botha, the technical lead, and along with me is Jensen Kunrad, the team captain, and Mark Townsend, the sustainability lead. Our team also includes Ahmed, Lana, Megan, Arya, and Denise, and we have our amazing teacher sponsor, Mr. Johnson. We also have our Invent Team Education Fellow, Mr. Paul Fusil from the Woods Hole Oceanographic Institution. A problem that we have noticed within our community and all around the nation is the presence of poor indoor air quality within schools and other crowded indoor spaces. Poor indoor air quality negatively impacts an individual's mental health, physical well-being, and academic performance. This poor indoor air quality is caused by the release of fossil fuel and other pollutants into the atmosphere. In the year of 2021 alone, thousands of fossil fuel plants from all around the world released 37.12 billion tons of CO2 emission into the atmosphere, further accelerating the devastating climate crisis. These pollutants then concentrate in indoor spaces because they have very little floor space and a high amount of people inside. And due to this, a shocking 50% of US schools have poor indoor air quality. Now, you might be asking yourself, why is poor indoor air quality so bad? Well, poor indoor air quality causes headache and irritates the eyes, nose, and throat. It also harms the cardiovascular system, aggravates respiratory conditions, and has been linked to cause depression and anxiety. Poor indoor air quality also increases school absenteeism and dropout rates while worsening school academic performance. To understand the target beneficiary more for our proposed problem, we surveyed 100 students at our school, 20 teachers, and 2 school district superintendents. 95% of students said that they were concerned about the impact poor indoor air quality had on our learning environment. 100% of teachers said that they would use our proposed invention to help fix this problem, and both superintendents were eager to get these devices in classroom. So as you can see here, we've really learned that this was an extremely important problem and are now very inspired and passionate to use our device and bring a good change to the world to make schools a cleaner and greener place.
Our solution to poor indoor school air quality, the Algae Air, is a small-scale, fully automated spirulina microalgae photobioreactor. But why algae? Algae naturally convert air pollution into oxygen and algae biomass. In fact, algae is 400 times more efficient than trees at removing carbon dioxide from the air, as the entire organism is photosynthetic. Our device uses technology to maximize algae air purification. For instance, we use an air bubbler to circulate air throughout the algae, ensuring all of it, and not just the top layer, is absorbing air pollution. Our device also uses other technology like LED lights with optimal light wavelengths to light the algae, as well as a heating pad to maintain proper algae temperatures. These technologies work with a real-time clock module, which maintains a 16-hour to 8-hour day-night cycle. This has been shown to maximize algae air purification, with light levels and heating decreasing during the night period. We also have done extensive data collection to see how our device impacts air quality over time. And you can see our graphs over here. We also have an application that accompanies our device so users can easily see algae health, air quality, and do device maintenance. We have conducted extensive experimentation to prove the effectiveness of our device. In fact, we created this air quality monitor shown here to see the air quality improvement caused by our device. We placed our device in an enclosed space over a period of 24 hours, this half-scale prototype, and found that it could be predicted to decrease CO2 levels by 100 parts per million in an average-sized classroom in just 1 month, with a full-scale model being predicted to do this by 800 parts per million in the same time frame. Our device requires occasional user maintenance. Our total dissolved solid sensor placed within the algae measures the algae concentration. When this concentration becomes too great, users are supposed to harvest the algae. This ensures that the algae remains in the load phase and continues converting air pollutants into oxygen and algae biomass instead of becoming stagnant.
You might be wondering, what will happen to all the algae that comes from our invention? Well, the main use of our algae biomass will be to create bioplastics, which are eco-friendly biodegradable plastics. As you can see, we have a adjustable formula that we can change to create slightly different plastics with slightly different properties. Spirulina algae with additional properties from glycerol and agar can create a plastic that's not just durable, but also environmentally friendly. By 3D modeling molds, we can shape our algae plastic into almost anything we want. This year, we have been focusing on creating the MIT dome, but we have also created molds for solitary bee habitats, plastic bags, and we have plans to replace the school's plastic cutlery and trash bags. Oh. On top of being used for plastic, algae can also be used as a fertilizer because of its high NPK ratio. Users of our invention can simply harvest the algae, dry it on a tray, and crush it up, mix it with water, and supply houseplants or plants in their garden to deliver the necessary nutrients they need to survive.
So our device takes this pollution from fossil fuel plants and converts it into useful algae biomass, all while improving air quality and fighting climate change.
So, you now might be wondering, how did we spend our budget this season? Well, we tracked all of our spending of our $7,500 budget in an Excel spreadsheet, and we broke it down into 3 main categories. The first of which was hardware and accounted for 20% of our spending and included things like wood, nuts, and bolts for our Algae Air device. The second and largest category was electronic, which was 51% of our spending and was for the main components of our Algae Air device. And the third category, which was 29%, was other miscellaneous costs, such as things for our Makerspace subscription. The majority of our spending was clustered in the months of December to January, as when we were working the hardest to build our first Algae Air prototype. As for communication, this season, we really wanted to help educate people about poor indoor air quality and Algae Air. So we use platforms like TikTok, YouTube, and Instagram to put out reels to educate people about our mission and connect to a global worldwide community. So if all of you could give us a follow, it'd be great. We're at OEHS Invent Team on all of our platforms. We also received lots of recognition from our local community and built really strong connections. We received recognition from Lauren Underwood, the Congresswoman, Stephanie Kifowitz, the State District Representative, the Kenton County District Board, SD308, our school district, the Foxville Makerspace, and local news outlets like Shaw Local and WSPY News.
You may be wondering, what are our next steps? Over the summer, we plan to apply for a non-provisional patent and finalize our device for initial testing within our own school district. We will also publish our app to the Google Play Store. After this initial testing next school year, then we can begin to finalize our device and pitch it to investors and then try to market it to other school districts, further expanding our impact. We would like to acknowledge many of the staff at our school, such as Mr. Johnson, Ms. Korzak, Mr. Dunn, Mr. Benters, Ms. Darnell, and Dr. Sparland for all the support they've given our team throughout the season. We would also like to thank our LMIT mentor, Mr. Paul Fusil, for all of his great contributions to our project. His advice was able to significantly improve the final outcome of our project, plus teach us so much more about the engineering design process and proper code structures. We'd also like to thank Mr. Dominic Fusil for his help with creating the patent drawings for our provisional patent. His advice was significantly able to improve our final drawings. We'd also like to thank lawyers Mr. Manav Das and Mr. Paul Hawley for their invaluable assistance with creating our provisional patent application, as well as Mr. Doug Kimberly from the Foxville Makerspace. He gave us access to the tools we needed to create our device, all while teaching us abilities like how to use a laser cutter for the first time. We'd also like to thank the Kendall County Board and SD308 School Board for recognizing our team, as well as all the support our family and friends gave us this project. Most importantly, we'd like to thank the Lemelson MIT team and Dr. Esther Brooks for all of the help they've given us this year. We are so thankful that we had the opportunity to develop our own invention, and it's been an honor and a privilege working with this group. We have learned so much throughout the season, and our team is committed to ensure that we continue invention education offerings at our school for years to come. Thank you.
At this time, there is, at the end of each student group, there is some Q&A time. And then later on, we'll have a little time at the end if you forget something real quick, you can jump in at the end. You're not going away yet.
When people ask questions, use the microphones.
Yeah, or if there's a second mic, I don't know, but we'll drop you. I can drop you. So we'll get the question in first. Oh, there's a mic right here. Yeah, you can step down to these mics. So if you have a question, you can step to the mics.
Enjoyed that. Enjoyed that. Let's see. What was the origin of your idea? How did you end up putting that together?
So the first thing that actually inspired us was that our school is surrounded by 5 different coal plants, and these are polluting our air. So our school has some of the worst air quality in the nation, and we were trying to find a way to solve this problem as it was impacting all of our learning ability. So Jensen stumbled upon the idea of algae, and she can talk a little bit about how algae air came to be from there.
So I learned that algae is really good at improving air quality. That's why I learned it was 400 times more efficient than trees. But the issue is, sorry, it's difficult to care for the algae in your classroom. Like, who can maintain this proper temperature, maintain the lighting conditions required to care for algae? That's why we developed our invention to automatically do all the maintenance required with your algae so that it can work to improve the air quality. We were really concerned about how this poor air quality could be impacting our health, especially after additional research about how it impacts academic performance, mental, and physical health. And we hope our device can make a difference, not only in our community, but others like it.
How would you figure out how much algae to use based on the air quality?
So what we wanted to do was maximize the amount of algae we can fit in our small-scale device. So currently we have a half-scale prototype, as I mentioned earlier. We wanted our device to still be rather small, as it can be very difficult to implement larger systems like an HVAC system. We did experimentation with this air quality monitor up here to see how algae impacted air quality over time, and that's how we came up with the final size of our algae. This room actually is pretty good air quality because it's so huge. We've been in other rooms here, though, where in a small and concentrated groups of people where the air quality can get quite bad. Mark, would you like to talk more about the process of making the bioplastics?
Sure. So, the process of creating bioplastics, it can take a couple weeks because first you need to harvest the algae, and when algae dries, it loses a lot of water weight because it's mostly water. So that can take a couple weeks, but you can just dry it on a tray. From a tray, I use a mortar and pestle, or you can use, if you have enough, you can use a blender or any food processor. So you just, you process it into as fine of a powder as you can, and then you mix it with a little bit of glycerol. It's not on the screen. Glycerol, it's fine. Which is a thick, viscous, clear liquid, and agar, which is kind of like a gelatin substitute. The importance of agar and spirulina algae is that they both have polymers that are polymers are what make plastic, but the polymers in agar and spirulina algae are biodegradable, which is what makes them special. The beeswax is really just to add some flexibility to the plastic. Depending on how much you add, you can make it more stiff or more flexible. And the glycerol, it acts as a crystal forming agent, which allows it to really form into a solid.
One thing that's really cool, that's a use for algae we didn't mention, is that spirulina algae is also a superfood. In fact, Mark's brother ate some of our algae. It's full of protein and many beneficial vitamins.
He's a gymnast. He needs a lot.
Just about the invention, is it powered through battery or does it need to be plugged into the wall?
Currently, it's plugged into the wall. We are working on implementing a solar panel to power it for our final version to mitigate its power draw.
Thank you.
On the app, what does it show you regarding the algae?
So essentially, as Jensen said, we have to harvest our algae triannually. So on the app, first, it shows real-time data of what your algae device is doing. So you can see how it's improving air quality. So that way you always know where your devices are. If you're implementing them in a school and you're an administrator, you can have all of your algae devices paired to this one app and manage them all from there. But it also push notifications to you about when you're supposed to harvest your algae so that you know, and then you go and take it. And it also has instructions on the app on how to harvest the algae properly and what you can turn it into, such as fertilizer, bioplastic, or any other use you might have for it.
So I have 2 questions. One is, could you describe a little bit more about the procedure of using the device and what will be the cost for inventing one device?
So the procedure to use the device is quite simple. So pretty much you just place the device in your classroom. The only maintenance needed is occasionally harvesting the algae. This is simply alerted through the app. As you can see, we have a countdown there. That's how long it's predicted to take until you'll harvest the algae based on the current total dissolved solids concentration, which is a measure of how dense the algae is. Once the algae is too dense, it stops converting air pollutants into algae biomass and oxygen effectively as it starts to slow growth due to being too dense. So that's why we occasionally have to harvest the algae. We do this through a user-friendly spigot system on the side of the device. You can simply just take a cup and use it just like a water cooler, but for algae. Then the other maintenance necessary is occasionally refilling our nutrient tank with nutrient solution. This is needed about tri-annually. So pretty much, we have a pH sensor inside the algae that automatically measures its pH. As this pH begins to shift, you have to add nutrient solution, as spirulina algae is an extremophile, needing very high pH values to thrive. That's part of the reason we chose spirulina, because these high pH values prevent any bacteria or harmful things from growing within the same liquid, which makes it very beneficial to keeping this air quality device clean and with just spirulina algae. So that's why a pump will automatically dispense nutrient solution into our algae, which the users will have to refill the tank it gets nutrient solution from triannually, as notified by our app as well.
For the cost of the device, it goes down with every version that we make because we are getting better at being cost effective. Right now, the landed cost for about one device would be around $200, but if you'd manufacture them in bulk, that price would go down. And we pledge to donate one Algae Air device for every 10 that we sell and give to school, because we are really all about creating accessibility to clean air quality, and that's a mission that we want to promote.
Hello. So I have two questions. So my first question is, you mentioned that you would have a projected decrease of around 800 parts per million. I'm assuming that's carbon dioxide, right? So would your device be able to deal with other emissions from coal plants, such as sulfur, mercury, or other toxins that might be polluting the air?
Yes, we have to start a device with PM2.5 particulate matter. Algae should be able to deal with that, although unfortunately it was considered too dangerous to pump PM2.5 particulate matter into a closed chamber to test with, as well as those other pollutants. But algae should be able to work with that as well.
And how much range would it be able to work with? Like, do you need to run any airflow specifically through your device to make sure that you're processing enough, or does it just stay stationary?
That's why our device has the air pump that circulates air throughout the algae. So there's a pump in the bottom that sucks air in and circulates.
And you would say, if in this room here, you'd probably need one or two devices to keep it at a good air quality level?
In this room, it's double the size of an average classroom, which is what we're working with. So yeah, you'd probably need 2 full-scale devices.
Gotcha, thank you.
Thank you. One thing that's kind of interesting that our device really tried to solve is the limitations of HVAC systems. That's what's often used, but they can cost $7,000 to implement. Plus, they can really only be implemented as a building's actually being constructed due to all the infrastructure changes required. And finally, they're only effective in classrooms on the exterior of buildings, as they simply take the pollutants and move them outside, which not only is not effective for classrooms on the interior of schools, but it actually harms our environment. If we're just taking pollution and moving it outside, it has no real impact on our environment. So our device actually takes this pollution and turns it into something useful, helping save our planet while improving our health.
What a great way to end, saving the planet and your health. So fantastic presentation, nice job by you and your teammates throughout the year to come up with your invention. So Mr. Westlake's gonna preload the next group